Hey friends, this is Jim here with Science Talk, and I wanted to talk about the topic that a viewer had suggested, and namely about the notion of CO2 supposedly lagging behind temperature. There are climate deniers, we all know they exist, and they basically state that, because CO2 lags behind temperature, therefore adding CO2 into the atmosphere in ever increasing amounts as humans are doing today is not warming the climate. Humans aren't the cause of things, so basically shut up and go home. So let's talk about that. Okay. Spoiler alert. I'll give you 5 seconds to stick your fingers in your ears if you don't want to know the result, but they're wrong. Okay. Anyway, so here's this person right here. An article in Science magazine illustrated that a rise in CO2, carbon dioxide, did not precede a rise in temperatures, but actually lagged behind temperature rises by 200 to 1,000 years. A rise in CO2 levels could not have caused a rise in temperature if it followed the temperature. Okay, so what's going on here? So let's just read through this little bit of a website I have here for you, which comes out of Skeptical Science. Okay. Over the last 500,000 years, our climate experienced long ice ages, regularly punctuated by brief warm periods called interglacials. Atmospheric CO2 closely matches the cycle, increasing by around 80 to 100 parts per million as Antarctic temperatures warm up to 10 degrees C. Warm up to. That's not saying the changes in Antarctica were 10 degrees C, but warming up to 10 degrees C. However, when you look closer, CO2 actually lags Antarctic temperature change by around 1,000 years. While this result was predicted 2 decades ago, and the citation is Laureus 1990, little note on that, a lot can happen in almost 30 years. It still surprises and confuses many. Does warming cause CO2 rise or the other way around? In actuality, the answer is both. So let's break this down. First of all, let's look at this graph right here. I don't know if you can see it. I have a whole bunch of other graphs I prepared that I'll show you in a bit. But this is CO2 versus temperature past 400,000 years. The carbon dioxide is the blue line, and the temperature is the red line. Sounds like a hockey rink. But anyway, so what we have here, we have CO2 levels in parts per million up to 290, and then we have the temperature change, and so that's temperature change. So it went from, like, say, minus 8 cooler and up to, say, 2 degrees warmer. Now, if you look at this, it really does track very closely. A further breaking down of this would indicate that perhaps is a lag. I'll get to that in more detail later. But if you look at this, they really do track very closely. Now, it's important to remember, this is kind of proxy data, meaning that we get ice cores and we look at the the trapped bubbles in there. We can measure the CO2 in it, so that we can get a direct measurement of. The proxy aspect is recreating the temperatures based on ice cores, based on sediment cores, based on del O18, del C13. I've discussed this in other videos. Please check them out. Also looking at dendrological tree rings stuff and tree cores. So the temperature recreations are based on all the evidence we get from those sources. But you have to remember the error involved the further back in time one goes. So you have to take that into consideration. They're saying 8 to 1,000 year lagging. Well, if the 800 to 1,000 years is within the the error margin, then you can say that's just due to randomness, and it's not necessarily really a forcing. You have to really look at that carefully. But this does show a strong correlation between CO2 and temperature. Okay, I made a lengthy video discussing the Milankovitch cycles and the eccentricity, which is the change in the shape of the Earth's orbit from nearly circular to elliptical. This is an exaggeration, but it's illustrative. The obliquity, which is the tilt of the axis between 22.5 to 24.5 degrees, and then the precession, which is the wobble of basically the orientation of the axis going through the poles as the Earth moves around the sun. It wobbled, and that wobble causes the Earth to change its north star from between Vega and Polaris. I really should have said Polaris here. Okay. And all this changes the amount of heat that comes into the planet. And that heat, orbital forcing, can change the climate, allowing ice ages to ice sheets to grow and ice sheets to recede. So that's what figure 2, the 3 main orbital variations. Okay. The combined effect of these orbital cycles cause long-term changes in the amount of sunlight reaching the surface at different seasons, particularly at high latitudes. You might, if you have not seen my Milankovitch video, please check it out. But the further tilted over the planet is, in other words, the more it goes through the 24, 25 degree tilt, the more solar energy can be received at higher latitude, actually causing a warming. So, and then when it tilts back to 22, it reduces that. So, at high latitudes, approximately 19,000, causing large amounts of ice to melt, flooding the oceans with fresh water. This influx of fresh water that disrupted the Atlantic Meridional Overturn Circulation, AMOC, causing a seesawing of heat, right? The conveyor belt. Remember, the conveyor belt is a heat distribution mechanism for the planet. Okay? Seesawing of heat between the hemispheres, and that's Shakun in 2012. That paper is being referenced. The southern hemisphere and its oceans warmed first, starting about 18,000 years ago. As the southern ocean warmed, the solubility of CO2 in water falls. I have said numerous times in my video, the solubility of gas is inversely related to temperature. In other words, if you increase the temperature of the water, the solubility of gas decreases. Right now, the oceans are absorbing a lot of the CO2. But as the oceans continue to warm, their ability to keep absorbing CO2 will go down. And that will leave more CO2 in the atmosphere, increasing the measurements, ppms, of CO2 in the atmosphere. In other words, it's going to make things worse. So this causes the ocean to give up more CO2, emitting it into the atmosphere. Now, this is all tied into thermohaline circulations and other mechanisms, but this right here, this is the cause of the lag that we see going back until about 1,000 years ago. In other words, if we look at the CO2 and temperature cycles from a million years ago to 1,000 years ago, any lag, and again, you'll take into account error, but any lag is going to be due to the delay in outgassing of CO2 from the oceans. CO2 is still going up, and then it goes up some more once the oceans start outgassing. So the outgassing CO2 from the ocean has several effects. The increased CO2 in the atmosphere amplifies the original warming. The relatively weak forcing from Milankovitch is insufficient to cause dramatic change, taking our climate out of an ice age called deglaciation. However, this is an important sentence, the amplifying effect of CO2 is consistent with the observed warming. Then CO2 from the Southern Ocean mixes with through the atmosphere, winds, Hadley cells, that kind of stuff, spreading the warming north. Tropical marine sediments record warming in the tropics around 1,000 years after Antarctic warming, around the same time as the CO2 rise. This is according to a paper from Stott in 2007. Ice cores in Greenland find that warming in the northern hemisphere lags the Antarctic CO2 rise, and this is Kalon in 2003. This is, by the way, a paper that the deniers like to cite, saying, oh, it's BS. But obviously these deniers didn't read the full paper because he explains what's going on. To claim that CO2 lag disproves the warming effect of CO2 displays a lack of understanding of the processes that drive Milankovitch cycles. A review of the peer-reviewed research in the past periods of deglaciation tells us several things. Deglaciation is not initiated by CO2, but by orbital cycles. CO2 amplifies the warming, which cannot be explained by orbital cycles alone. CO2 spreads warming throughout the planet. Overall, more than 90% of the glacial interglacial warming occurs after the atmospheric CO2 increases. Let me repeat that again. More than 90% of the glacial interglacial warming occurs after the atmospheric CO2 increases, meaning the temperature is responding to CO2. The CO2 goes up, so does the temperature. And this graph shows it. This blue line is temperature. Okay. This pinkish line with the yellow dots, that's CO2. Let's scroll down to look at the figure description. The global proxy temperatures in blue as deviations from the early Holocene. This is the Holocene, okay, which is about 11.5 to 6.5 thousand years ago. KYR is kilo years, so 1,000 years ago. An Antarctic ice core composite temperature record in red. That's red. Okay, it looks pinkish to me. Whatever. An atmospheric CO2 concentration are the yellow dots. And then they identify the Holocene, the Younger Dryas, the boiling Alarode period, the oldest Dryas, and then this is the last glacial maximum. And you can see how low the CO2 levels were right there. It starts warming. Right? This dip here, right, the Younger Dryas. The dip right there. Now, let me go over to here. This is kind of another little summation. Jeez. All right. So what about the lag time? In the past, CO2 levels rose after temperature rose. Does this indicate rising CO2 levels today are an effect of, not a cause of rising temperatures? Answer, the natural progression of ice ages and the observed increase in the global average temperatures since industrialization have two very different drivers. Ice ages are driven by natural triggers. Recent warming is not. There it is. Basically, figure one, which is off here on the side, and I have graphs I'll show you later, shows how current atmospheric CO2 levels are about 400 parts per million, which is the highest concentration in 650,000 years. I just did recent videos of, that we reached levels not seen in 3 million years and may soon pass levels not seen since the Paleocene, Eocene thermal maximum of 56 million years ago for CO2 levels. This huge increase is due to human activity. The start and end of ice ages are natural processes. Right? So they're basically saying the same thing as the what I showed you on the other tab. Ice core analysis does reveal an increase in CO2 did lag behind increasing temperature at the end of recent ice ages, but the progression of ice age as well as the retreat of an ice age is helped along by various feedback processes. Although the increase in temperature occurs prior to an increase in CO2, carbon dioxide plays an important role in the retreat of an ice age. As CO2 in the atmosphere increases, the greenhouse effect is strengthened and a greater degree of warming occurs. Let me repeat that. As CO2 in the atmosphere increases, the greenhouse effect is strengthened and a greater degree of warming occurs. What is happening now? Exactly what this sentence is describing. It is important to remember that the lag time between temp and CO2 is relatively small, might even be within errors when compared to the overall process. Although it can be several hundred years, the time it takes to transition from an ice age to interglacial can be measured in thousands of years. In other words, relatively quickly. All right, so let me pull up some figures here to you can see better the temperature thing. Confused me. Here's that figure from that last slide. You can see it better here. So here's the CO2, 390. This is a little while ago. So we start from 800,000 years and to 0, which is basically present time. And if you look, okay, CO2 is in purple, temperature is in blue, and even if there is a lag, these things are closely correlated. I mean, here, right here, if you look at about 700,000 years ago, it looks like CO2 is lagging slightly. But overall, you know, a couple of things here and there, there's a little mismatch, but they tightly follow each other. Look at this, really tightly follow each other. I can say there's a lot more noise here. So this is showing a very close correlation. But the important thing to remember is that before human activity started, it might have been orbital forcing driving CO2 temperature and whether there's ice sheets or not. Human activity, by dumping all that CO2 in there, we're amplifying the greenhouse effect and increasing the temperature, which will then cause more melting. And that is really where it ties into. Okay. I showed that in a previous video. And this is just CO2 levels in ppms. Previous peak, this is 300 to 325,000 years ago. Well, of course, we've blown past that. And this is a 10-year projection. So, as you can see, it's increasing rapidly. I've shown that graphic in a previous video when I talked about CO2 and temperatures over the Earth's history. All right, now this is Antarctic temperatures, and then looking at CO2 in parts per million. And once again, you can see how very closely they track each other. Very closely. Some minor differences here. You know, there might be sometimes a little bit of a lag, but they follow each other very closely. You know, this one decreased more rapidly here around 400,000 years ago. This took a little longer to decrease. Okay. Perhaps a bit of a lag. The drawdown may not have been quick enough. You know, absorption by the ocean, absorption by plants. But you look at this, and lag time or not, they closely track each other very well. This is a really excellent graph. CO2 and temperature of our planet from 800,000 years ago until the present day. So CO2 is in blue, temperature is in red. And I'm sounding like a broken record here, or should I say skipping the CD. But basically, once again, look how closely tight they are. Might be, if you look closely, you can see some bit of lagging of the CO2, but they follow each other more closely. In fact, as the temperature rises with more CO2, the CO2 lingering further in the atmosphere, once things cool down, probably helps melt back some ice sheets. Until then, there's a lag in growing the ice sheets again. But there's no doubt that CO2 and temperature are closely related with the levels. And yet another graph showing this, CO2 in this particular graph is in red, as indicated by here, and temperature is in blue. and starting again from 800,000 years ago. And we can see this is probably some of the examples of the lagging that the data indicates. But if you look here, this looks like CO2 is preceding temperature. In other words, this temperature is increasing in response to a higher level of CO2. Here, they're almost identical, tracking extremely closely, etc. And also keep in mind, the closer we get to current time, the less error there will be in our estimate of the temperature and the CO2. So that's just a model of the normal Halene circulation. So let me play this little video here. Let me first look at this guy. Okay, so temperature of the lower atmosphere the last 400,000 years, looking at Antarctic and atmospheric data, and then this is the CO2 data. And, you know, it's kind of green. I wish there was a bold in like this one here, or different colors. Probably not showing up very well on your screen. My apologies for that, but again, we see the, so from numerous sources, they're all showing the same thing. All showing the same thing. CO2 and temperature are closely intertwined, and they do drive climate. So I want to play this video. Climate Denial Crock of the Week. And the host is Peter Sinclair.
The climate denial industry is reliant on a kind of magic, the ability of professional deceivers to create an illusion that settled science is somehow unsettled, that certainty is somehow uncertain, and even in some cases, selecting and distorting real scientific research and making it appear to say exactly the opposite of what it says. A perfect example is this widely quoted canard, best exemplified in The Great Global Warming Swindle, a 2007 movie that's become the hysterically bonkers Bible of the climate denial movement.
Here we're looking at the ice core record from Vostok, and in the red we see temperature going up from early time to later time at a very key interval when we came out of a glaciation. And we see the temperature going up, and then we see the CO2 coming up. CO2 lags behind that increase. It's got an 800-year lag. So temperature is leading CO2 by 800 years.
So the fundamental assumption, the most fundamental assumption of the whole theory of climate change due to humans is shown to be wrong.
So the movie claims to cite Antarctic ice cores to pretend that somehow, somewhere, actual data contradicts the overwhelming mainstream consensus about global climate change.
Today, together, you and I are going to learn the rest of the story.
Ever since scientists realized that the Earth's ice sheets have expanded and contracted many times over the last 3 million years, they have wondered what would possibly have been the cause of these grand climatic cycles. They're reasonably sure it's not because of this. By the 1970s, several peer-reviewed studies confirmed the current view that long-term changes in Earth's orbit and rotation have been the timer, the initial forcing that moves the planet into and out of glacial periods. They were named Milankovitch factors, after Milutin Milankovitch, the Serbian mathematician who first advanced the theory. There are 3 main factors.
Now, just a reminder, I did an extensive video examining the Milankovitch cycle. If you haven't seen it, please check it out.
The first one is precession. This refers to slow change in the direction of the Earth's axis of rotation, much like a rotating top. The process takes about 22,000 years. The second is obliquity, the subtle change in the angle of the axial tilt. from 22.1 degrees to 24.5 degrees, which occurs over about 41,000 years. The third is eccentricity, in which the shape of the Earth's orbit changes from nearly circular to more elliptical or egg-shaped over about 100,000 years. Paleoclimate expert Richard Alley gave a clear demonstration of one of.
I just want to point something out to you here. The sun is at one of the foci of the ellipse, not in the geometric center. So when the Earth is way out here, there's less heat that will reach the surface versus over here. This, of course, is perigee, and this would be apogee in the Earth's orbit around the sun. So again, I refer you to the lengthy Milankovitch video that I made about a month or two ago.
Or egg-shaped over about 100,000 years. Paleoclimate expert Richard Alley gave a clear demonstration of one of these effects in recent testimony before the U.S. Congress.
Good question. There have been these back and forth between on glaciers and the melting that we've seen over and over again. Why did it happen then if these same factors that you're blaming it on didn't exist then?
I can give you as much or as little answer as that you would like.
Give me 15 seconds.
Okay, give me 30 if I may.
Okay,
The ice ages are caused by features of Earth's orbit. Your brightness is the sun. This is the Earth.
Right.
This is the equator. Here's the North Pole.
Yes.
If the North Pole stood straight up, you could never give me a sunburn on my bald spot. But in fact, as you know, it is tipped over a little bit, and it nods a little more and a little less over 41,000 years. Now, when it nods more,
Right.
my bald spot ice melts, and the equator is a little more shaded, and now the ice grows, and now the ice melts. But it takes 41,000 years for this change to happen. We know what that's doing right now, and it's not fast enough to explain what we're seeing.
Tell me all of the up.
The cycles sometimes work together and sometimes cancel each other out. But the end result is, about every 100,000 years, the planet goes into and out of a glacial period, what many people call an ice age. The Milankovitch forces moved the planet out of the last glacial period, starting about 20,000 years ago. In the absence of human interference, another major cooling event would not be expected for at least 20 or 30,000 years. But the theory was incomplete. The orbital forcings are very weak. Scientists needed to show how such tiny perturbations could create huge global effects.
I just want to make a comment here that this video is a few years old. Recent analysis shows that, with putting aside human anthropogenic effects, we should be entering a cooling phase. Earth should be cooling down. What the time frame may be is another, is open to speculation and requires further analyses, but the Earth should be entering a cooling phase. I want to make that point clear.
During the 1980s and 90s, scientists like James Hansen of NASA and others worked to understand how such a relatively weak forcing could cause the kind of major global changes that would produce large planetary effects. They understood that other factors were at work to amplify small changes. For instance, increases in snow and ice cover increase the reflection of heat, amplifying a weak orbital cooling.
That's albedo,
But
reflecting
how
the
could
sun.
changes taking place primarily in the northern hemisphere be spread over the whole planet? The missing link, they said, was the increased warming of water and soils, releasing greenhouse gases, CO2 and methane. Hansen and his group wrote in 1990, changes in CO2 and methane content have played a significant part in the glacial interglacial climate changes by amplifying the relatively weak orbital forcing and by constituting a link between northern and southern hemisphere climates. To prove the truth of this sequence of changes, Hansen and his team called for more ice core studies and more accurate measurements. It is these very studies that have given us enough detail to show that Hansen was right about greenhouse gas effects. And these very studies are the ones deniers have chosen to cherry pick and distort. Those who've watched this series for a while.
And remember, all this ice core work, all the measuring the isotope fractionation, all the work of Wally Broker.
I'll know that I always like to go to the source of any claim that climate deniers make. In this case, a study by Nicolas Caillon, published in Science in March of 2003, which of course we'll actually read. It's titled Timing of Atmospheric CO2 and Antarctic Temperature Changes Across Termination 3. Termination 3 refers to the warming that brought the planet out of a previous glacial period, 240,000 years ago. What the graph shows is good support for Milankovitch theory as well as Hansen's prediction. Orbital factors begin a long, slow warming trend, which causes the outgassing of CO2 and methane from oceans and soils, reinforcing and amplifying the weak orbital warming and creating dramatic global change. The study says, the sequence of events is in full agreement with the idea that CO2 plays, through its greenhouse effect, a key role in amplifying the initial orbital forcing. And the situation at termination 3 is different from recent anthropogenic CO2 increase. We should distinguish between internal influences, such as the deglacial CO2 increase, and external influences, such as the anthropogenic CO2 increase on the climate system. Although the recent CO2 increase has clearly been imposed first as a result of anthropogenic activities, it naturally takes, at termination 3, some time for CO2 to outgas from the ocean once it starts to react to a climate change that is first felt in the atmosphere. And finally, the sequence of events during this termination is fully consistent with CO2 participating in the latter 4,200 years of the warming. The radiative forcing due to CO2 may serve as an amplifier of the initial orbital forcing, which is then further amplified by fast atmospheric feedbacks that are also at work for the present day and future climate. Could the authors have made it any clearer? In fact, Nicolas Caillon has moved on to other fields, and the de facto corresponding author on this paper is Jeff Severinghouse of the Scripps Oceanographic Institute. Responding to my email, Dr. Severinghouse graciously took time from his schedule to review the earlier version of this video. He gave me permission to display his response. So let's review. We know that orbital forces have not acted significantly in 10,000 years, nor will they for another 30,000. We know that the sun has not been a significant factor in the last 50 years. We've seen how James Hansen and his team predicted the interplay of orbital effects and greenhouse gases.
A quick comment about what they just said about the sun. There are other people who say that it's the sun's output that's causing the planet to warm, that the sun is increasing its output. And basically studies examining that very question have indicated that that is not the case, that the contribution of solar output is not significant, anywhere from maybe 4% to 11%, depending on the paper that you're looking at. So the general consensus is that the influence of the sun can be not considered important, can be negligible. Is negligible.
10 years before the actual data became available. And we've seen how the very study climate deniers hope you won't read is used to twist and distort the debate, when in fact it proves how well climate scientists have understood and predicted greenhouse effects. The majority of climate deniers are unknowing pawns who have been manipulated by fear and ignorance to continue spreading a few carefully crafted propaganda memes. As I've studied this debate, the wonder has been always and always the depths of dishonesty and cynicism that are common practice among the paid professional denier community. Let's continue to cut through the ignorance and spread the truth right here at Climate Denial, Crock of the Week.
What it comes down to is that when it comes to the glacials and the interglacials, orbital forcing is probably the driver, but the reason why there is a lag in the CO2 is because of outgassing from the oceans. Because as you warm up the ocean, the solubility of the gases decreases, and therefore it's released. That's the key thing. But when you look at what's happening in the recent 150 to 200 years, then you can see that it's the burning of the fossil fuel putting the CO2 levels up into the atmosphere. And as I showed you earlier, the CO2 will amplify the warming and help melt ice sheets and help increase temperatures. So to say that humans are not causing what's going on is complete bullshit. Humans are causing what's going on. And the data is there to back that up. So I thank you for your time. I hope that answers that question, the topic, and we'll talk soon. Hey folks, this is Jim here reminding you to please subscribe to my channel and please share my videos with others. Also remember to click the bell so that you know when I drop in a new video. I also ask that you please consider becoming a patron of my channel and support the work that I do by going to patreon.com/Science Talk with Jim Massa, each word separated by an underscore, and becoming a patron. It's asking for as little as $3 a month, cost of a cup of coffee, to support the work I do and keep my informative videos coming your way. Thank you for your support.